LeetCode 28. Find the index of the first occurrence in a string in JavaScript. This is a medium rare question. It's not that hard. It's a sort of sliding window. Given the two strings, needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. Example 1, haystack, sad but sad, needle, sad. Output 0. Sad occurs at index 0 and 6. The first occurrence is at index 0, so we return 0. They're essentially asking for string.search or string.indexOf to be re-implemented in your own code. It's not a very creative question. It's a bad idea to actually do this. It's essentially only a mental exercise. It's a test to see if you can do it. If you ever get the opportunity to write your own index of, don't. Just use index of, string.prototype.indexOf, or string.prototype.search, or regular expressions, or whatever your language, if it's not JavaScript, offers for that. Here's how I've implemented the algorithm using the computer sciencey way for LeetCode. And this will always be slower, less concise, and more error prone than using the built-in native methods. But here's how I did it. We start an outer loop, looping through each character of the outer of the haystack. We start with the first character in our loop, and then we look in the needle, and we check to see if the first character of the needle matches the character we're on in the outer loop. And if it doesn't, we continue on the outer loop. If it does, then we continue on the inner loop, and we check the next character against the next character, subsequent character in the outer loop of the haystack. So we start at 0 on the haystack, and then we start at 0 on the needle. We pass that 0 test, and we go to 1 in the needle. So then we go to 0 plus 1 on the haystack. We match that, and we check 0 plus 2 in the needle, and we check our 0 plus 2 on the haystack, and it matches that, and then we're done. The way I've implemented this in the code is exactly how I've described it to you here. And so if we were to just say, given a haystack of sad and a needle of sad, I've set it up as such. We have, first of all, if there's not a needle, that means, for example, if needle is the empty string, then it's converted to false in Boolean. So we'll return 0. So if we get the empty string, we return 0. The next thing is I get the needle's length. The next thing I do is get the end. That's where we stop looking in the haystack. We stop looking in the haystack when there is no possibility for that needle to be found. So if we get through all of these characters, and we had 2 characters left in our haystack, and our needle has 3 characters, then the needle can't possibly fit in the haystack, and therefore we've reached the end. So until we get up to here, we haven't reached the end. Once we've reached up to here, this is the last time we can go. And then we check, oh, there's only 2 more characters here, and there's 3 in our needle, only 2 in the haystack, 3 in the needle, but only 2 remain in the haystack, so therefore we've reached the end. That's how this is calculated. The haystack length plus 1 minus the length of the needle. Why plus 1? Well, you can think about it. If we take this plus 1 out, and we just have haystack length minus needle length, and the haystack is SAD, and the needle is SAD, and so 3 minus 3 is 0. And then we start our loop for I is 0. If I is less than 0, well, 0 is not less than 0, so we would automatically fail our first case here. And that's why we need to have this 1 extra on end. And the reason for that is that string indexes are going to be 0 based. So we need to start that at 0, even that's the first character. That's the 0th character is the first character. And that's why we have to have that extra 1 in there, because otherwise we'll be off by 1, as I just demonstrated. So we begin our outer loop. I is 0, I is less than end, I plus plus. And what is end? End is right before is enough characters to fit our needle. So if we've reached the end, it means that we don't have enough characters left to fit our needle in there. So we start out at 0, and then we start out at 0 again for our inner loop on our needle loop. The J loop is our needle loop. In fact, I should have labeled this as, instead of outer, as labeled it as haystack. That kind of makes more sense, but we'll leave it as outer. For J is 0, J is less than n len. That's the needle length, J plus plus. If the character at index J, that's needle 0, is not equal to, well, what is I now? I is 0 and J is 0. Haystack 0, then we continue the outer. Okay, so character at needle 0 is S, and character at haystack 0 plus 0, which is 0, is also S. See that right there? There's our haystack. Okay, so we're going to keep going in the inner loop, in our J loop, and we have J plus plus. If needle 1, which is A, is not equal to 0 plus 1, remember I is still 0. Okay, so haystack 1 is also A. Okay, so now we're going to keep going on our inner loop, J plus plus, and now J is 2. So needle 2 is D, and haystack 2 is also D. Okay, so now we have completed the needle. Okay, so now we're going to return I, because we've completed the needle. And that's the only time we complete the needle. Or we return I's when we've completed the needle. And the needle is what? Remember, I started out at 0, so that's where we started out at. However, if we didn't have this, if we had SAW, then we would obviously get to needle 2, and haystack 2 would be W. Needle 2 is D, and haystack 2 would be W, and that would obviously not be a match. So in that case, we would continue to outer. And then outer, we would increment 1, right? I gets incremented as 1. And then we go to again, so I is 1. And we check to see if 1 is less than end. Well, no, end is 1, so then we're going to stop there in that case. So we would stop right away, because I is 1 and end is 1, and 1 is not less than 1. And then in that case, we would return -1. So that's essentially how this algorithm works. Like I said, it's a medium problem, but it's really not that hard. It's a really straightforward problem. And that's how you solve it in JavaScript. At least that's how I solved it, using a sliding window, which is kind of a computer sciencey way, but it'd be much better to use index of, which they don't want you to do, or use a regular expression, which they probably also don't want you to do. But maybe that's actually a fair way to solve it. I don't know. I don't know what the rules are on this. So there you have it. LeetCode 28 in JavaScript.